Good morning or good afternoon, depends on where you are. This is my presentation of an object detection and its educational effect on aspiring film directors using computer vision and machine learning by me and a partner of me. Let's begin. So this is the things we'll be going through today: an introduction of the paper, the algorithm we used, and the method or the challenges. And second, the challenges that we faced pre-development and during development, and perhaps like some future considerations on post-development of the algorithm. Third, the solution, the method we used to overcome the pre-development challenges, and the overall process of how we developed the overall algorithm. Fourth, the experiment which we used to test the reliability of the algorithm and to see whether specific details we need to add on and to perfect. And fifth, the conclusion of the overall benefits and the use of and the potential of the algorithm that we developed. So first, introduction. This paper is a paper about object detection that is used in the field of film. So first of all, what is object detection? It is used very oftenly these years. People use object detection like machine learning models to detect specific objects that appears in different images that can be used in various fields, as you can already see. Such as Tesla uses object detection to develop their self-driving vehicles, and some medical field researchers use object detection to analyze their CT scans or X-ray scans to analyze small abnormal development of tissues, or as in a lot of smartphones, we have facial detection and et cetera, et cetera. And the benefits are, of course, that object detection is much more faster, is much more accurate, and it's more specific with all the recorded details and metadata that is far more accurate than human memory and paper and pencil recording. And of course, there are challenges as well, which is firstly, this paper was firstly designed to use object detection in the field of film, to support, to discover the potential of object detection, not only in the real, not only in the physical world, but only in the visual world, in the field of cinematics. So since object detection have a wide range of potential, the choice of features that could be used in the field of cinematics is hard. But after a serious consideration, the specific feature that was chosen to be focused on with movie props. Almost every movie uses props of some sorts to create plot devices or settings and environments. In terms of movie props, they would generally be reused across multiple scenes or in different shots. And if object detection is able to detect specific objects in different scenes, we could know whether each prop should or need to be used in different scenes. And it also applies to different characters as well. And the second challenge is the choice of different technologies, since object detection is a very hot topic, and there are a lot of well-functioning, well-rounded different types of object detection models just out there. it's really hard to pick one and use. And after some, consideration and research, we decided to use ELO v5, which is a pre-trained object detection model that is developed by PyTorch. And to achieve the whole app development, we used Flask that which is the basis of a server, and which uses to connect the algorithm and the user interface, which is developed by Flutter. And the third challenge we run into is the design of experiment to test the reliability of the algorithm. Since computer detection is really sometimes unpredictable, and sometimes it can get 100% correct, but sometimes you just don't know whether the algorithm consider a specific portion of the image to be a specific object. So it's really hard to design an experiment that could test the reliability of the algorithm. But after all, we managed to pull it off. And let me introduce the tool we used. As I already mentioned some before, we used ELO v5x. So ELO v5 is the pre-trained object detection machine learning model we used. X stands for the size of it, and as you can see, it's the largest of the 5 of the ELO v5 models. And we use pandas. Pandas is just a Python library that was used to manipulate the data outputted by the ELO v5x model. And we used Flask, that it's a server development app that is used to connect the algorithm and the user interface. And as you can see on the right, this is the overview of the solution. So first we have a movie video, and different scenes are cut out between in different time throughout the movie, and it's calculated and inputted into the algorithm, which the output is connect to the Flask server, and as well as a database. And all of this, after calculations and results, everything will be printed onto the app, which is the user interface. And this is the specific details of the solution and methods we used. So to address all the possible errors and details, we decided to use as widest range as possible of categories of object, and that of images that we use to test the model and to train it. Although it's pre-trained, we tested limits to know more details about it, such as sports gear, stationaries, fruits, vegetables, and etc., etc. Then the model is tested according to different criterias. Image have only one type of object, image containing multiple types of objects, and also objects with intersecting, overlapping, or how do I say this, with some level of intersection and almost completely overlapping. And after testing and training, the overall algorithm is completed and built into a application with a complete user interface. And after all that, it is the time to design an experiment to test the reliability, the accuracy of the overall algorithm, which the experiment that will be used to test the effectiveness of the application at identifying the location props in a movie is the carefully selected inputs of 30 different images. The images are selected based on how different they are from each other in terms of the background and setting, as well as the object itself is to be detected. For example, one image features a brightly colored ball in a grassy field, while another image features perhaps a house located in a mountain region. As you can see, all the results here. Here is the numerical results, and here is it presented in a chart, bar chart version. As you can see, really, object detection is an unpredictable device that we can use. Sometimes it predicts as highly as to 100%, but sometimes it can get as low as 30%, as shown in the 24th image presented here. I can, based on this result, we have the conclusion that it is overall accurate, but we still need further training of this algorithm to make it more well-rounded, to make it more perfect. And yeah. Well, the conclusion is basically whatever everything I have just said. Object detection, as you can see, have its benefits and its pros and cons. It is definitely more accurate, as it can return specific coordinates of different objects that is appearing in the image. But it also have its cons, which is the unpredictability of its algorithm, since all the math, everything is done behind the scenes, which you cannot see. But like, different to human visualization, we see different images. Our brain functions, and we come up with the conclusion that that image is a specific object. But object detection model is just so unpredictable that it just requires much more training to make it more perfect. And yeah, so thank you for listening to my stuttering presentation.